Hello everyone, welcome to Knowledge Planet powered by Physics Wallah. So today is our ultimate recap session for our chapter number 1, that is Basic Mathematics. Today we will recap all the things, all the topics we have studied in this chapter. So let's start our chapter's recap without wasting any time. So in today's lecture we will be covering basic algebra and trigonometry, arithmetic and geometric progressions, then differentiation, and then integration. So this is all the basic mathematics that we have to study our physics. Okay, so let's start with basic algebra, that is solutions of quadratic equation. Now what is a quadratic equation? Any equation in which the highest power of x is 2, that is called a quadratic equation. So quadratic equations are the polynomial equations of degree 2. Degree 2, it means the highest power of variable can be 2. If I say the general form of quadratic equation, then f is equal to ax square plus bx plus c is equal to 0. This is a general form of quadratic equation where a, b and c are real numbers and a cannot be 0. Why a can't be 0? Because if a is 0, then this will become a linear equation. So if I have a general equation ax square plus bx plus c is equal to 0. Now what is the solution of this quadratic equation? The solution of this quadratic equation is minus b plus minus under root of b square minus 4ac divided by 2a. This is my solution of this general quadratic equation. Now see, depending upon the plus and minus, we have two roots to this equation. So we will have one x1 and one x2. So a quadratic equation will have two roots of the equation. X is equal to x1. Let's take alpha and beta. So if my two roots of the quadratic equation are alpha and beta, then these are those values of x which satisfy this equation. That is, for those values of x for which ax square plus bx plus c is equal to 0. If these are two roots of quadratic equation, then the sum of these two roots is equal to minus of b by a, and the multiplication of these two roots is equal to c by a, where a, b, c are our coefficients of x square, x, and the constant term c. Okay, let's move forward to trigonometry. What is a angle? How is plane angle defined? See, if this is my circle of radius r and we have an arc of length L which subtends a theta angle at the center, okay, which is subtending some theta angle at the center, then this, if L is the length of an arc and theta is the angle subtended by the arc at the center of a circle of radius small r, then according to the definition of plane angle, this theta is the ratio of arc upon radius. Okay, this theta is the ratio of arc upon radius. Theta is the ratio of arc to radius, and this theta we will get in radians. Okay, we will get this theta in radians. Now radians is my SI unit for measuring plane angle. Till now we have measured angle in degrees, but now we will use the SI unit to measure angle, that is radians. When we divide the arc length by the radius, we get theta in radians. Now what is the interconversion between degree and radian? So the interconversion between degree and radian is that 180 degree is equal to pi radians. Okay, 180 degree is equal to pi radians. From this we can follow that 1 degree is equal to pi by 180 radians, and 1 radian is equal to 1 by 80. So we have 180 degree is equal to pi radians. So from here we will get 1 degree is equal to pi by 180 radians. This is how we convert degree to radians, and if I say 1 radian, then 1 radian is equal to 180 by pi degrees. Okay, 1 radian is equal to 180 by pi degrees. This is how we can convert an angle from degree to radians. Now see, we know that we have 6 basic trigonometric functions: sine, cosine, tangent, cotangent, secant and cosecant. Okay, so for some fixed values of angles 0 degree, 30 degree, 45 degree, 60 degree and 90 degree, we need to remember the values. I hope we all have studied these values in the 10th standard as well, and we remember these values, that sine 0 is 0, sine 30 1 by 2, sine 45 1 by root 2, sine 60 root 3 by 2, sine 91, and the cos is reverse of this, 1 root 3 by 2, 1 by root 2, 1 by 2 and 0. Then tan is the ratio of sine by cos. Cotangent is 1 by cos, inverse of cos. Tan, it is reciprocal. Cotangent is reciprocal of tan. So cot theta is equal to 1 by tan theta. Similarly, cosecant is reciprocal of sine. Cosecant theta is 1 by sine theta, and secant is reciprocal of cos. Cos secant theta is equal to 1 by cos theta. Instead of all these angles, there are some more angles for which you have to remember the values of sine and cos. That is, sine of 37 degrees is equal to 3 by 5. Similarly, cos 37 degrees is equal to 4 by 5. And the next one is sine of 53 degrees is equal to 4 by 5, and cos of 53 degrees is equal to 3 by 5. So in addition to these angles, we need to remember the values of these trigonometric functions for 37 and 53 degree as well, because these angles are frequently used in a physics question. Now let's find values of these trigonometric functions for lead angles. Now if I have a Cartesian coordinate system, then we measure angle this. The anti-clockwise direction of measuring theta is taken as positive and clockwise is taken as negative. Okay. Now we can define a complete 360 degree angle or 2 pi radian angle in 4 quadrants, that is 0 degree, 90 degree, 180 degree, 270 degree and then again 360 degree. Now how to define angle? If my angle lies between 0 to 90, if my angle lies between 0 to 90, that is in first quadrant, we can write it as simply theta or 90 minus theta. We can write it as, if I have to define some angle of this much, we can write it as theta or 90 minus theta. This is how we can define that angle. In second quadrant, we can define it as 90 plus theta or 180 minus theta. Then in third quadrant, we can define it as 180 plus theta, 270 minus theta. Third quadrant, 270 plus theta or 360 minus theta or minus theta also. This is also written as minus theta. Okay. So this is how we can define angle in our 4 quadrants. Now we have to check which trigonometric ratios are positive in which quadrant. From 0 to 90, if my angle lies between 0 to 90, all trigonometric ratios are positive. From 90 to 180, sine is positive. Now, if sine is positive, 1 by sine cosecant is also positive. Okay, if sine is positive, then 1 by sine cosecant will also be positive. And then from 180 to 270, tan is positive, and then from 270 to 360, cos is positive. See, if tan is positive here, then cot will also be positive here, because cot is 1 by tan. And if cos is positive here, then secant will also be positive here. Let's write them also. So cosecant is positive here, then cot will also be positive here, and then secant will also be positive here. Now, how to remember this? We can remember this by all school to college, all school to college, or add sugar to coffee. We can remember it using this: all school to college, or add sugar to coffee. All sine, tan, cosine. All sine, tan, cosine. Okay, this is how we can remember this. Now, if I have to find sine of 180 minus theta or cos of 90 plus theta, if I have to find such angles, suppose I want to find sine of 150 degree. Okay, suppose I want to find sine of 150 degree, then I don't know what sine of 150 is, but I can write it as sine of 180 minus 30, or I can write it as sine of 90 plus 60. Now, if I know how to find these angles, then I can calculate sine of 150 degree. So, this is where lead angles are used. Okay. Now, if I have to find sine of 90 plus theta, then first step is check the quadrant of the angle. Check the quadrant of angle. Now see, check the quadrant of angle 90 plus theta. Now 90 plus theta comes in second quadrant. Okay. Now check the trigonometric. Now check whether the given trigonometric function is positive or negative in this quadrant. Okay. Check if given trigonometric function is positive or negative in this quadrant. Okay, in this quadrant. Now see, for sine of, suppose we are calculating sine of 90 plus theta, then 90 plus theta comes in second quadrant. It comes in second quadrant. In second quadrant, sine is positive, so we will write a plus sign. If sine was negative, then we will mark a negative over here. Okay. Then third step is, if angle is given as, if angle is 90 plus minus theta or 270 plus minus theta. Okay. If my angle is expressed in the form of 90 plus minus theta or 270 plus minus theta, that is integer, odd integer multiple of 90 degree, then trigonometric function will change. Then trigonometric function will change. Now, which function changes into which function? Sine will change to cos, and if cos is given, it will change to sine. Okay. Tan will change to cot, and cot will change to tan. Secant will change to cosecant, and cosecant will change to secant. Okay. Now because angle is given as 90 plus theta, so function will change. Now sine is the function, so sine will change into cos. So we will write cos of theta. Now we can find cos theta. So this is how lead angles are used. Okay. Now see, if angle is given as, if angle is given as 180 plus minus theta or 360 plus minus theta, that is even integer multiple of 90 degree, then trigonometric function will not change. Then trigonometric function will not change. Okay. Then a trigonometric function will not change. Now see students, if I have to find cos of 180 minus theta. Now see, 180 minus theta, first step, check the quadrant. Quadrant is second. Now check the function is positive or negative in this quadrant. Cos, it is negative in this quadrant. So 180 minus theta goes to second quadrant. Cos is negative, write a minus sign. Okay, write a minus sign. Then angle is expressed as 180 minus theta. So function will not change. We will write cos and then theta. Okay. This is how we use lead angles. So in case of lead angles, if I have sine of 150, I can express it as sine of 90 plus 60, and then I can use lead angles to calculate it. And similarly, I can express it as sine of 180 minus 30. Then also we can calculate it easily. Okay. So this is how it works. Now let's move forward. These are some important trigonometric formulae, that sine of a plus b is equal to sine a cos b plus cos a sine b. Then similarly, sine a minus b, sine a cos b minus cos a sine b. Cos of a plus b, cos a cos b minus sine a sine b. Cos of a minus b, cos a cos b plus sine a sine b. Then sine 2 theta is 2 sine theta cos theta. Cos of 2 theta is cos square theta minus sine square theta. And 1 plus cos of 2 theta is 2 cos square theta. 1 minus cos 2 theta is 2 sine square theta. Okay, so these are some important trigonometric formulae which you have to remember. Now there is small angle approximation. Okay, small angle approximation says that if theta is very small, okay, if theta is very small, if my theta is very small, then sine of theta is approximately equal to theta. Similarly, tan of theta is also approximately equal to theta, and cos of theta is approximately equal to 1. Okay, if my theta is very small, then sine theta is approximately equal to theta, tan theta is also approximately equal to theta, and cos theta is approximately equal to 1. Okay, now move forward to binomial approximation. What does binomial approximation says that? Binomial approximation says that if we have 1 plus x raised to the power n, okay, if we have 1 plus x raised to the power n, then this can be written as 1 as it is, plus the power will come forward in multiplication with x only and only if x is much less than 1. Okay, only if x is very smaller than 1. Okay, if x is very less than 1, then 1 plus x raised to the power n can be written as 1 plus nx. Similarly, 1 minus x raised to the power n can be written as 1 minus nx only and only if x is much less than 1. Okay, only and only if x is much less than 1, then we can write 1 plus x raised to the power n as 1 plus nx, and 1 minus x raised to the power n as 1 minus nx. Next is arithmetic progression. So what is arithmetic progression? Arithmetic progression is a series of numbers in which each number is there is a fixed common difference between two numbers. That is, each next number is obtained by adding a fixed number to the previous one. Okay, arithmetic progression is a series of numbers in which each next number is found by adding a fixed number, adding a fixed amount to the previous one. Okay, so if I have first term as a and the fixed number is d, then next number will be a plus d, then add d to this number, next number will be a plus 2d, then a plus 3d, and then a plus 4d up till so on. This is an arithmetic progression. This is an arithmetic progression in which there is a fixed common difference between two consecutive terms. Okay, fixed common difference between any two consecutive terms. Such a series is called arithmetic progression, where d is our common difference, d is our common difference, and a is our first term. Okay, a is our first term. Now see, example is 3, 6, 9, 12. See, each number is having a difference of 3 from the previous one. So 3 plus 3 is 6, 6 plus 3 9, 9 plus 3 12. So if a1, a2, a3, this forms an AP. Okay, this is an AP. Then what we will have is a2 minus a1 is equal to a3 minus a2 is equal to a4 minus a3 is equal to d. The sum of the difference of two consecutive terms is fixed. Okay, this is called an arithmetic progression. See, 3 plus 3 6, 6 plus 3 9, 9 plus 3 12, 12 plus 3 15, 15 plus 3 18, 18 plus 3 21, and so on. So each term is having an addition of 3, okay, to obtain the next term. This is an arithmetic progression. So if I have an arithmetic progression whose d is the common difference, okay, if d is the common difference and a is my first term, and a is my first term of an arithmetic progression, then what will be the nth term? Okay, if I am given the first term and the common difference, and I asked you to find the 60th term of this arithmetic progression, then a nth will be equal to, or simply write it as an will be equal to a plus n minus 1 into d. Okay, what is the formula of nth term? A plus n minus 1 into d. And if I have to find the sum of n terms of an arithmetic progression, okay, so if I ask you to find the sum of first 10 terms of this AP, some AP is given 2, 4, 6, 8, 10, 12. This AP is given to you. Find the sum of first 10 terms. So the sum of n terms of an AP is n by 2 into 2a plus n minus 1 into d. Okay, this is my sum of n terms of an AP. There is one more formula. So Sn is equal to n by 2 a plus an. The sum of first and the nth term multiplied by n by 2 gives us the sum of n terms of an AP. Okay, so this is all about arithmetic progression. Next comes the geometric progression. see, just like in arithmetic progression, the common difference between two consecutive terms is same. If we subtract two consecutive terms, then we get a fixed number. In geometric progression, each succeeding term is a multiple, fixed multiple of the preceding term. Okay, that is, ratio of two consecutive terms is constant. Okay, it is a sequence in which ratio of two consecutive terms is constant. Like if we multiply 2 with 2, we get 4. Then multiply 4 with 2, we get 8. Multiply 8 with 2 is get 16. 16 2s are 32. 32 into 2 is 64. So each next term is a multiplied by fixed number to obtain the next term. Okay, each preceding term is multiplied with the fixed number to obtain the next term, and that fixed number is called common ratio. Okay, so if my first term is a, then I multiply it with some number r, so the next term will be ar. Then again multiply this number r, it will be ar square, then ar cube, a into r to the power 4, and so on. This will form an geometric progression. Okay, where r is the common ratio. Okay, r is the common ratio. R is called common ratio, and a is our first term of the geometric progression. Each succeeding term is produced by multiplying each preceding term by a fixed number, and that fixed number is called common ratio. Okay, now if a1, a2, a3, a4, all they form a GP, all of them form a geometric progression, then the ratio of a2 by a1 will be equal to ratio of a3 by a2 will be equal to ratio of a4 by a3 will be equal to r. So the ratio of two consecutive terms is always a constant. Okay, now see nth term of an GP. If we are given a geometric progression and we have to find its nth term, then nth term of an GP is given by a into r raised to the power n minus 1, where r is a common ratio, a is our first term. So nth term of my GP is a into r raised to the power n minus 1. Sum of n terms of an GP. So sum of n terms of an GP is a into r raised to the power n minus 1 divided by r minus 1, where r cannot be equal to 1. Okay, where r cannot be equal to 1, this r must not be equal to 1. So this is the sum of first n terms of an GP. Similarly, if we have a GP and I have to find sum of infinite terms of an GP, okay, sum of infinite terms of an GP, then this is equal to a upon 1 minus r. Okay, this is equal to a upon 1 minus r, and this is very important as it is used many times. Okay, so sum of infinite terms of an GP is a upon 1 minus r. This is all about arithmetic and geometric progressions. Let's move forward to graphs. So there is a very important graph, straight line graph. So if we have this as x-axis and this as y-axis, then this is a straight line in the xy plane. So the equation of a straight line is y is equal to mx plus c. So this is the general form of equation of a straight line. This is the equation of a straight line, where m is the slope of the line. Okay, where m is the slope of the line. M is the slope of the line. So what is slope? So The steepness of the line tells us the slope if this angle is theta. Okay, if the angle made by the line with positive x-axis is theta, and we have 2 points on this line, x1, y1 and x2, y2, then what will be my slope? Then slope is equal to tan theta. Slope is equal to tan theta, which is also equal to y2 minus y1 divided by x2 minus x1. So this is the formula of slope for a straight line. That slope is tan theta or y2 minus y1 by x2 minus x1. The intercept, okay, the intercept on y-axis, y-intercept. What is intercept? Intercept is a point where the line cuts the axis. So this y-intercept is C, okay, where C is my y-intercept, okay. M is my slope and C is y-intercept, the point where the line cuts the y-axis, okay. So this is the general equation of a straight line. Then y is equal to mx plus c, where m is the slope. M can be found using two formulas: tan of theta if angle is given, and x1 y1, or if 2 points are given, x1 y1 and x2 y2, then m is equal to y2 minus y1 divided by x2 minus x1, and the c is the y-intercept, that is the point where this straight line cuts the y-axis, okay. Now let's move forward to differentiation. Now what is differentiation? See, if we have a function, if we have a y which is a function of x, it means y is dependent on x, okay. It means y is dependent on x. Now y is a function of x, y is dependent on x. If I do a small change in x, then y will change, okay. If I do a small change in x, then y will change. Now if I want to find the rate of change of y with respect to x, okay, so rate of change of y with respect to x, this will be equal to change in y divided by change in x. What is, if I change the x by some delta x amount, then y will change accordingly by some delta y amount. So what will be the rate of change of y with respect to x? It will be delta y by delta x. This is my rate of change of y with respect to x. Suppose if my y is changing very much continuously, if my y is changing very much continuously with x, and I take a this much big interval, now in this interval the value of y has increased and decreased many times, but if I take this interval, I won't be able to know that how many times this value has been changed within this interval. So to find the change in such a case, what we do is we take a very small interval dx, okay. We take a very small interval of x dx, such that in this the y changes by a very small amount dy, okay, such that in this y changes by very small amount dx. I will take a very small interval, very small, such that this dx is almost infinitesimally small, almost zero, negligible, and we have the change in y as dy. Then in such a case, okay, and then in such a case, what we have applied is rate of change of y with respect to x, in this case we have applied that limit on delta x tends to 0, delta y by delta, okay, we have found the rate, okay, we have found the rate by applying the limit that this dx is very small, this dx is very small. The interval I chose earlier, I have reduced it to very small values such that it is almost 0, such that it is almost 0. So we have the limit delta x tends to 0, rate will become dy by dx, okay, rate will become dy by dx. Now if I have to find the slope of a line, it tells me the rate of change of y coordinate with respect to x, delta y by delta x, y2 minus y1 by x2 minus x1. But in straight line the slope is constant, okay, the slope is constant, so we can find it. But in this case the slope is not constant. So in such a case, what we do is we draw a tangent at the point where we have to find the slope, okay. Then the slope of this tangent, gives me the slope of this curve at the point. Now see, this interval is very small, such that it corresponds to a point. Now see, if I see in this interval of dy, the curve is almost a straight line and the slope is also a straight line. This is my dx and this is my dy. Then the slope of this tangent will be equal to dy by dx, okay. Then the slope of this tangent will be equal to dy by dx. So what is the physical significance of differentiation? The physical significance of differentiation is that it gives me the slope of the curve at any point. If we calculate the value of differentiation at any point, then it gives me the slope of the curve at that point, plus it gives me the rate of change of y with respect to x, okay, it gives me the rate of change of y with respect to x. So this is the physical significance of slope. Now just like we have addition, subtraction, multiplication and division as mathematical operators, differentiation is also a mathematical operator. We have a fixed differentiation rules for fixed functions, okay, like differentiation of sin x will be cos x, okay. If my fx is defined, then its differentiation, we will apply this operator on that function, then we will get the answer, okay. What is physical significance? Dy by dx tells us the slope of the curve at that point, plus it gives us the rate of change of y with respect to x. Now see, differentiation of constant is 0. Differentiation constant doesn't changes, it's a fixed value, so change in constant is 0. That is why differentiation of a constant is 0. Now this d by dx is the differential operator. This is the differential operator. When we apply it on some function, then we will get result. Just like multiplication is an operator, okay. When we multiply a number with some another, we get something. So if I apply the differentiation operator on x raised to the power n, then I will always get this. This is how it is followed, okay. So differentiation of x raised to the power n is n will come forward, reduce the power of x by 1. You have to remember all these differentiations for fixed functions, okay. So d by dx of x raised to the power n is n into x raised to the power n minus 1. Sin x is cos x, differentiation of cos x is sin, differentiation of tan x is secant square x, differentiation of cot x is minus cosecant square x, differentiation of secant x is tan x into secant x. Differentiation of cosecant x is minus cot x into cosecant x. Differentiation of log of x is 1 by x. Differentiation of exponential x is exponential x only. And differentiation of a raised to the power x is a raised to the power x logarithm of a. Okay. So this is the differentiation of some fixed function. Now then there are some rules of differentiation. Okay. If we have a y is a function of x and c is a constant. Okay. Y is a function of x and c is a constant. I want to find the differentiation of c multiplied by y. Now this c is a constant. It will come out of the differentiation. The operator will be applied only on y. Okay. So this will become c will come out d by dx of y, dy by dx. Now if we have two functions, okay, we have two functions of x. One is u, that is a function of x, and v is also a function of x. And I want to find the differentiation of u plus v. I want to find the differentiation of sum of two functions. Example is d by dx of x square plus sin x. Okay. I want to find the differentiation of sum of two functions. Differentiation of sum of two functions. Then this will applied on both the functions one by one. It will be du by dx plus dv by dx. Similar goes for subtraction. D by dx of u minus v is equal to du by dx minus dv by dx. If I have multiplication of two functions, then differentiation of u into v is, first apply this operator on u, keep v as it is. So this will become du by dx into v. Then apply this operator on v, keeping u as constant. So u will remain as it is. We will take differentiation of v, that is dv by dx. So d by dx of u into v is du by dx into v plus u into dv by dx. Next is, if I have differentiation of division of two functions, if I have differentiation of u by v, then this will become, we will keep as it is, differentiate the numerator first. Okay. Keep the denominator as it is, differentiate the numerator, then put a minus sign. Now keep the numerator as it is, differentiate the denominator, divide this whole by v square. So d by dx of u by v is equal to v as it is, du by dx minus u as it is, dv by dx. Divide this whole term by v square. Okay. These are the rules of differentiation. Now there is one more rule, chain rule. So what chain rule says that, suppose we have y is equal to sine of x cube. Okay. Now I have to find dy by. Now we know the rule of finding the differentiation of sine x. D by dx of sine x is cos x, but here we have x cube. Okay. So whenever a function is given instead of x, a function of x is given instead of x, then we apply the chain rule. What chain rule says that? What chain rule says that dy by dx will be equal to, differentiate the function with respect to x cube first. Okay. Differentiate it in the same way we would be differentiating if x was present over here. Okay. So differentiation of sine x is cos x. So differentiation of sine x cube will become cos x cube. Okay. But now because we were not given x, we were given some function of x instead of it. So differentiate this function further. Okay. So differentiate this function further. It will become cos of x cube into 3x square. Okay. This will become cos of x cube into 3x square. So what does chain rule says that? First differentiate the function in the same way as we would have been differentiating if x was given. Okay, if x was given instead of this function of x, so differentiation of sine x is cos x, so differentiation of sine x will be cos x cube. Now because we were not given x in the original function, we were given a function of x. Okay, x cube was given instead of x, so further differentiate this x cube with respect to x. Okay, this is what chain rule says that. So this is all about differentiation. Let's move to integration. Okay, let's move to integration. Now what integration is? Integration is just the opposite of difference. Okay, integration is just the opposite of differentiation. If we are given that y is a function of x, okay, if we are given that y is a function of, now see, if I want to find the area of this function of x, okay, if I want to find the area of this function of x, then what is the one method? That I will divide this area into strips of width delta x. Okay, I will divide this area into strips of width delta x and then calculate the y over here, then calculate the y over for this strip, then calculate the y for this strip, this, like this on. Now I can find this area. The area of this strip will be y1 into delta x. Area of this strip will be y2 into delta x. Area of this strip will be y3 into delta x, because these are rectangles. But in this method, see, we are always leaving some area which is not able to calculate. We are always leaving this area which we are not able to calculate. So by this method, this area is left out. So the answer we will get is not. So the answer which we will get will not be correct. So further, extending this method further, we can find the area of this curve using integration. See, if this is my x and this is my function y, which is a function of x, I divide this. I divide this area into many curves. Okay, I divide this area into many strips such that these are of very small width. Okay, I divide this area into a number of strips having very small separation dx. Okay, so these width are these strips are having very small dx separation. Now see, the value of y is almost a constant and we are not missing any area. Okay, this dx is so small that value of y is almost a constant for this strip. Okay, value of y is almost a constant for this strip. Then the area of this strip will be y dx. Then the area of this strip will be y dx. Now total area will be sum of, total area will be, in if we take bigger strips, the total area was summation of y delta x. Now we have, when we were taking the strips of delta x width, when we were missing this area, okay, when we were missing out this area, the total area can be represented as summation of y into delta x. Now we have taken strips of very small width such that y is almost constant. Now total area will be the sum of area of all strips, sum of area of all strips. So first strip will have some value y1 into dx, then y2 into dx, then y3 into dx up till so on, because these strips are of infinitesimally small width, and we will have infinite number of strips. Okay, we will have infinite number of such strips. So the total area will be integration of y dx. Okay, so the total area will be integration of y dx. When we reduce this delta x by very small amount, then this summation turns into integration. Integration means summing up, compiling it all together. Okay, so what does integration physical significance is? Integration tells us the area under the curve. Okay, integration tells us the area under the curve. This is called integration of y dx. Okay, this is called integration of y with respect to x. Integration of y with respect to. Now integration is of two types. One is indefinite and the other one is definite. Okay, in indefinite integration we integrate y dx simply. Okay, in definite integration we integrate y with between two limits. Okay, we integrate y with respect to x between two limits, that is we are finding the area between two limits. We are finding the area from x1 to x2 only. Okay, we are finding the area from x1 to x2 only. In definite integration, indefinite, we add a constant after integration. We add a constant after integration, and in definite integrals no constant is added because the constant is summed up when we put the limits. Okay, no constant is added because the constant is compensated when we put the limits. Okay, now x1 is called the lower limit and x2 is called the upper limit. X1 is called the lower limit and is written on the lower side of the integration sign, and x2 is called the upper limit. Just like differentiation, integration is also an operator. When we integrate a function, we get a definite function. So there is definite integrals of some definite functions. Okay, so what is the integration of some functions? Integration of dx will give us x plus a constant c. Integration of x raised to the power n will give me x raised to the power n plus 1 divided by n plus 1. Increase the power by 1, write the same power in the denominator. Okay, increase the power by 1 and write the same power. In differentiation we decrease the power by 1, in integration we increase the power by 1. Okay, now n cannot be equal to minus 1 over here. Okay, this rule is only applied for values other than n is equal to minus 1. N can't be equal to minus 1. Integration of sin x is minus cos x. Integration of cos x is sin x. Similarly, integration of secant square x is tan x. Then integration of tan x into secant x is secant x. See, integration goes just opposite to differentiation. Differentiation of secant x is tan x into secant x. So tan x into secant x integration will be secant x. Similarly, integration of cosecant square x is minus cot x. Integration of cot x into cosecant x is minus cosecant x. Integration of exponential x is exponential x. Exponential is x is such a function that its differentiation is also exponential x, its integration is also exponential x. Integration of 1 by x is log of x. Okay, integration of 1 by x is log of x. Now there are rules of integration as well, just like differentiation. Now if we have y is a function of x and c is a constant, okay, y is a function of x and c is a constant, and we want to find the integration of c into y, some constant multiplied by y, then this is a constant, it will come out of the integral, only integration of y with respect to x will be left out. So this will become c times integration of y dx. If we have two functions g of x and h of x, okay, if we have two functions u and v, both are dependent on x, then the integration of sum of two functions, okay, integration of sum of two functions, example x plus sin x, integration of x plus sin x, the integration of sum of two functions will be equal to integration of u plus integration of v. Similarly, subtraction of u minus v, integration of u minus v will be equal to integration of u minus integration of v. So these are the rules of integration. Now definite integration, how we put the limits in definite integration. In definite integration, we integrate the function between two limits x1 to x2. Now see, example, let's take it by example. Integration of x raised to the power 2, integration of x raised to the power 2 d from 1 to 2, okay. So this 1 is a lower limit, x1 is a lower limit, x2 is the upper limit. So integration of x raised to the power 2 from 1 to 2. First we have to integrate this function according to the fixed functions only, okay. First we have to integrate it according to indefinite integral only, find its integration, then we have to substitute the limits. So integration of x square, it will be increase the power by 1, write the same power in the denominator. Now because it is definite integration, we will not write any constant and put the limits from 1 to 2. So this will become integration of x cube by 3 limit 1 to 2. Now this 3 is a constant, it will come out. How to substitute the limits, okay? Limits will be substituted only in x. So substitute the upper limit first. Substitute the upper limit first. It means substitute 2 in place of x. Substitute 2 in place of x. So it will become 2 cube minus, substitute 1 in place of x, it will become 1 cube. So always put upper limit first, substitute upper limit, then put a minus sign, then substitute lower limit, okay. First integrate, then substitute upper limit, then put a minus sign, then substitute lower limit. So write 2 in place of x, it will become 2 cube, put a minus sign, then write 1 in place of x. So this will become 8 minus 1, that is 7 by 3, okay. 7 by 3 will be our answer, okay. Now see, there is one more rule for integration. When a linear function of x is present instead of x, suppose we are integrating sine of 4x plus 3. Now we know that integration of sine x is minus cos x, but here a linear function means highest power is 1, okay. Linear function, general form of linear function is ax plus b. Okay, this is the general form of linear function ax plus b. Linear functions mean the highest power of x can be 1. But now when a linear function is present instead of x, what we will do? First integrate the function as we would have been doing if x was present, okay. Integrate the function as we would have been doing if x was present. So integration of sine x is minus cos x. So integration of sine of 4x plus 3 will be minus cos of 4x plus 3. Then divide the whole term. Divide the whole term by coefficient of Okay, divide the whole term by coefficient of x. First, integrate the function in the same way as we would have been doing if x was present. So integration of sine x is cos minus cos. So integration of sine of 4x plus 3 will be minus cos of 4x plus 3. Now because a linear function was present instead of x, so divide this by coefficient of x. What is coefficient of x? This 4 is the coefficient of x. So divide it by minus cos of 4x plus 3, cos of 4x plus 3 divided by coefficient of x, that is 4 plus c. This will be our answer. Okay, this will be our answer. If linear function is present in place of x, then we will integrate it by this way. So this is all about a quick recap of a first chapter, basic mathematics. This is all what we need to know in basic mathematics to do our physics calculations and derivations further. I hope this was quite interesting for you and a quick recap also. I hope you remembered everything I have taught you in the classes. So very well done. All the best. Keep studying. Work hard. Good to see you. Take care. Bye bye.